Hey guys, Miss Fearing here. Welcome to Unit 6, Notes 3, Exponential Growth. So yesterday we went and we started talking about what does an exponential function look like, how do we graph one. Today we're going to kind of branch off of that a little bit and look specifically at exponential growth equations. So equations that are getting bigger, are increasing, going up, whichever way you kind of want to look at it, but we call them exponential growth. So here's the equation that we are going to use when we're looking at exponential growth. It is y equals c times 1 plus r to the t power. C is going to be our initial amount. R is our rate of change, and we always want this to be expressed as a fraction or a decimal. Usually it's going to give it to us as a percent, so we're going to have to change that into a decimal before putting it into our equation. And then t is going to be our time. So this is very similar to what we looked at yesterday. So in Unit 6, Notes 2, we kind of talked about y equals a times b to the x. And that was the equation we looked at. Well, they're very similar. A and c are both still our starting points. So this is where we started yesterday, or that was our y-intercept. So this is going to be the same thing. That's our initial amount, and that's going to be our y-intercept. And our exponent here is an x. Here we use a t. Those can be interchangeable, so this could also be an x. Okay, it could also be an x. Either way you want to write it. Usually when we're talking about time, we write it as a t, but we could write it either way. Now the only thing that's kind of new to us is this 1 plus r, and what this says is that I have 100% plus my r percent. So I'm starting with 100% and I am increasing more percentages. So that's why we have the plus sign. That's what tells us we're increasing as well. So let's go ahead and look at an example here. Example number 1, I have c equal to 8 and r equal to 0.5. First thing I always look at is my rate a decimal without a percent sign? In this situation it is, so we can go ahead and plug it right into our exponential growth equation. So I have y equals c, well that's my 8, times 1 plus my rate, 0.45, all to the t or the x power. So because we're just graphing this, I use it as the x power. We aren't actually talking about time right yet. So that's why that's an x for right now. Now, just like yesterday, our x values are going to stay the same, -2, -1, 0, 1, 2, 3. And we're going to plug those into the exponent and get our y value. So in your calculator, you want to make sure that you are plugging in y equals, or you're going to push 8, parenthesis 1 plus 0.41, parenthesis caret key, and then your exponent. When I did that, I got 3.81. Plugging in -1, I got 5.52. Plug in a 0, remember that's my y-intercept, that's where I'm starting from. So I got 8, which is exactly where we started from. Our c value is where we start from, so that's good. When I plug in a 1, I got 11.6. 2, I got 16.82. And then plug in 3, I got 24.39. So make sure you're plugging these values in and checking your answers to make sure that you're getting the same thing I'm getting. Now we want to go ahead and we want to graph these. So at -2, I'm at 3.81. At 1, I'm at 5.52. 0, I'm up at 8. 1, I'm up at 11.6. 2, I'm up at 16.8. So almost to 17 there. And then 3, I'm all the way up at 24, somewhere up here. So remember yesterday we kind of talked about how this is going to be a curve shape. It's not a straight line, although this one looks kind of straight. But this is not a straight line. And then we also talked about how you should never, ever, ever cross this x-axis down here. So you want kind of that curve shape that doesn't cross that x-axis. So now we're going to go ahead and look at example number 2 here. Always, always, always the first thing I look for is my r a fraction or a decimal without a percent sign? And it is. So we can go straight into our equation now. So I'm going to get y equals c, which is 6 in our case, times 1 plus my r, all to the t power, or in this case, again, since we're not talking about time, I'm going to use an x. We're going to use the same x values that we're used to, -2, -1, 0, 1, 2, 3. and we're going to plug that x value in for x to get our y. So in your calculator, you're going to be hitting 6 parenthesis 1 plus. Now, we want that 1/3 to be a group. So in order to tell our calculator that it's a group, we're going to put that in parentheses as well. Close both of the parentheses, hit your caret key, and then hit -2. So if I go ahead and do that, I got 3.38. Plug in a -1, I got 4.5. 0, remember, is our y-intercept or our starting point. Well, I can look at my equation and see that right away. It's my c value, so 0 is 6. Plug in a 1, I got 8. 2 gave me 10.67. And 3 gave me 14.2. Again, really make sure that you are checking this on your calculator so that you know you're plugging it in right. So I'm going to graph this now. I get -2, 3.38, -1, 4.5, 0, 6, 1, 8, 2 is 10.67, and 3 is up at 14.2. So I want to be careful when I graph this. I don't want to cross the x-axis, and I don't want to cross that 4 value. And I want to make sure it gives that curved. Now, the other thing you want to kind of look for when you're looking at these is your graph making the right shape? If this is an increasing value, when you read this graph from left to right, so if I look at it going this way, it is getting bigger, it is getting higher and higher and higher. So I know that this is increasing, which since this is my plus, I do want an increasing value, so I know that I'm on the right track. Example number 3 here, we're going to do word problem. In 1971, there were 294,105 females in high school sports. Since then, the number has increased. It's increasing at an average rate of 8.5% per year. So I have a starting amount. That's my C value, so I have that. And I have a rate. Now, the big issue I have right now with my rate is it's as a percent, so we need to change that into a decimal. So to do that, we divide by 100, or we take that decimal point and we move it 2 times to the left. So if I move it 2 times to the left, I get 0.085. So that's going to be my R now. So I can write an equation to represent number of females that participate in high school sports since 1971. So that's going to be y equals my starting amount, 294,105, times 1 plus my rate as a decimal, not a percent. And then since we are talking about time, now I'm going to raise it to the t power. Part B then says, according to the equation, how many females participated in sports in 2005? Well, this was the number in 1971, and it wants me to get to 2005. So I have to figure out how many years have gone by so I can plug that in for the t value. So I'm going to do 2005 minus 1971. If I do that, I end up getting 34. So I'm going to plug 34 in for t. So I'm going to get 294,105 times 1 plus 0.085, all to the 34th power. If I plug that into my calculator, I get something that looks like 4,711,004.36. So be very careful when you are looking at this. We cannot have 0.36 of a female or of a person. So we want to go ahead and we want to make sure that we round that to the nearest whole person. So my final answer would be 4,711,005 females. Make sure that you are labeling these with what we're talking about. So example number 4 here, in 2010, the city of Farmington had a population of 21,087 and a growth rate of 1.9% per year. So I want to write an equation that represents the population of Farmington since 2010. So I have my C value, my starting point, and I have my rate. But the issue again is that my rate is as a percent, so we want to change that into a decimal first. So I get 0.019, just move that over twice. Now I can write that equation. So I get 21,087 times 1 plus 0.019. Again, we're talking about years, so I'm going to use the t exponent. So part B has 2 different questions. I want to know what's the population of Farmington going to be in 2013, and 2017. So we're going to do 2013 first. So I need to see how much time has gone by from 2010 to 2013. So I'm going to subtract those. And I actually want to do, I want to do the bigger number minus the smaller number. So I want to do 2013 minus 2010. I'm going to get 3 years for that. So we're going to plug 3 in for our time that's gone by. When I plug that into a calculator, I get 22,311.94. So again, we can't have 0.94 of a person, so we're going to round that up to be 22,312 people. So I want you to go ahead and I want you to try to figure out how many people there'll be in 2017. Pause the video, try it on your own, and then come back and check your answer. So when I did this, you have to subtract your years to figure out how much time has gone by. Put that in for our exponent. And then again, you can't have 0.59 people, so we got to round up to the nearest whole person. I got 24,057. If you didn't get that, please come check with me before moving on to the next problem. So now number 5 is going to be a problem that kind of brings us back to think about what we did yesterday. I have an initial population of 750 endangered turtles that triples each year. We want to write an equation and then find out the population after 8 years. So this doesn't give me a percent increase. It doesn't say I'm increasing each year by this percent or this rate. It just tells me that I'm tripling each year. So that actually tells me I'm going to go back to my y equals a times b to the x power or to the t power, because I know my starting amount and I know that it triples. So that's actually just my growth rate right away. So if I were to write that equation, I would get y equals 750 times my growth rate is just b to the x or to the t, because we are talking about years, so you could put a t in there. So now I'm just going to plug in that 8 into that exponent to see how much my population would be in 8 years. And I get a really, really big number when I put this in my calculator. I get 4,920,750 turtles. So that's it for the notes today. Your next step is going to be practice. Go ahead and come chat with me if you have any questions.